Now, if you happen to be watching the last video and you're coming to this video, the thing I said at the end of the last video was wrong. I thought I was going to be implementing flat map next so we could have multiple generators inside here. But what I'm going to do is implement filtering first. So we're going to want to write something like this if statement right here. If I is greater than 2, then yield that. So what I'm going to do, I also added some comments here. So I noted that this first section works because for each is defined. So this is a for loop with the do keyword. This one works because map is defined. And that's because this is a for expression with a single generator right here. And now what would happen is if I came down here and I tried to create another for expression, I'll need a different variable name here. Let me go back to, how about AS equals that? And then what I want to do is I want to say if X greater than 2, then print line on AS right there. And when I try to save that, you'll see the usual error message. By now you're getting used to this. And it says value with filter is not a member sequence event. So again, that would be better if it said method with filter needs to be defined inside of sequence event if this is what you want to do. But we've already seen this error message, so we know what that means. And now we just need to know how to implement with filter inside of here. And if you recall how the filter method works, one thing I should note is that in earlier versions of Scala, instead of defining with filter as shown here, you would define a filter method inside of sequence to get this to work. And then at some point after Scala 2.11.7, that message changed. The implementation changed, I guess I should say, and now we define with filter instead of filter to make this work. So what I'm thinking right now is what I've shown before is if you have a collection list, 1, 2, 3, 4, like that, and then you want to run a filter method on that one and say, I want to keep the integers that are greater than 2, something like that. So currently the list contains integers. So this is going to transform an integer here to a Boolean value over here. And that's because this is a Boolean test. So that's the way filter works, is it takes an anonymous function that transforms whatever's in the list, the generic type A in our case, into a Boolean value. So whatever you pass into filter must always return a Boolean value there in the end. And we can see that. I believe I have that in the book here. Yeah. So filter and with filter are both going to be implemented the same way. They're going to take a function, an anonymous function like this one, or a real function or a method right here. And this is the type of signature that that would have to take. And the way filter works in the end, I forgot to mention that, filter is going to return the same elements that are inside of the initial collection. So in my case, that would return 3 and 4 because those are greater than 2. So when filter is called on a list, it's going to return a list, and then it's also going to return the same data type that's inside of the list. So int here and int here. And with filter, I believe, has the exact same signature, if I remember right. And indeed, that's what I do down here. So let's get rid of that and come back up here. And now we want a with filter method. So we'll say with filter. And again, that takes a function or what we call a predicate in this case, because it transforms our A value into a Boolean over here. And as I mentioned, with filter is going to return the same type. So our type is a sequence. So it's going to return that same type. And it's going to be a sequence of A because our current sequence contains the type A. That's exactly what we're going to return here. And now we just need to implement the body over here. And it turns out that this algorithm is very similar to that one. So I'm going to copy and paste that in there like that. And now say, well, the new sequence is just going to be filtered here. So I will call filter right there. So I was calling map. Now I'll just call filter. And everything else should be exactly the same. So let me walk through that just for a moment for my own benefit. So we have the array buffer. I'm going to filter that array buffer on the predicate that's passed in. So that's a predicate P that's passed in. Then, as I noted with this example here, I need to transform that into a sequence. And I do that because I want to pass this in here as a var args parameter. When we create a new sequence, that's going to be returned by with filter. So I believe all of that code looks correct to me. And let me save that. And whoops, sorry. I had the type B in here, and this does not have the type B. Map requires a type B because map can potentially transform an A into a B. With filter does not do that. It's going to return the exact same type that was in the collection initially. So let me save that. And then there we go. So now we see this last line of output is this list 6, 8, and 10. And that's because of the way it's working. So it's saying elements that are greater than 2. So that's 3, 4, and 5. And then it doubles those elements. And that's how we get 6, 8, and 10 right there. So now I can add this comment here and say that this example here works because with filter is defined. So again, notice that I'm just going step by step through here, and I'm implementing the methods inside of our sequence class to allow this different functionality inside of for expressions down here. And I believe we just have one more step to do, and that's to allow multiple generators to be used right there. And we'll do that in the next video. Oops, sorry, I thought it was done, but I'm not quite done. I knew there was something different about with filter, and I couldn't remember what it was off the top of my head. So what happens here, so if we look at the section filter versus with filter, there's a article here about how yield works, how for and yield expressions work, or for expressions work. And the short story is that for comprehensions with if filters are translated to with filter method calls. What happens is if with filter does not exist on the class, the compiler will fall back and use the class's filter method. But a problem with that is that you'll actually get compiler warning messages. So that's why I'm implementing with filter instead of filter. And then I note in this next line that if neither one exists, the compilation attempt will fail. But if I had implemented filter in this lesson instead of with filter, then we'd see this warning message right here. So I was creating with filter to get rid of that warning message, but I did not technically create with filter exactly the way it's supposed to be created. And I wrote about this in this blog post here. So if you want to read more about that, check out this article right here on my website. And what happens is that with filter is supposed to create a non-strict filter of the traversable collection. So basically with filter is supposed to be implemented in a lazy way. And I'm not doing that. I'm just saying go ahead and filter this using here. But again, the purpose of these videos is not to show how to implement this code, but only to show that when you implement this code properly, then things will start working inside of for expressions. So I am not too worried about this at this time. As I mentioned later in this video course, we're going to create a linked list from scratch, and I might show how to implement with filter properly at that point. But either way, the key for our lesson is that when you implement with filter, or if you implement filter, then you will see that you can now write code like that inside of your for expressions. That's the purpose of this lesson.